video, we will look into the multiplicative principle using set notation. When it comes to combining sets using multiplication, the Cartesian product is the best representation of this combination of two sets. Let's take a look at the Cartesian product. Given sets A and B, we can form the set A cross B, or the Cartesian product between A and B, as the set of all coordinates x, y, such that x is in A and y is in B, to be the set of all ordered pairs x, y, where x is an element of A and y is an element of B. We call A cross B the Cartesian product of A and B. Okay, so now let's use the Cartesian product to count in an example. Suppose we have set A as the set containing 1 and 2, and B is going to be the set 3, 4, 5. Now, what does the Cartesian product look like? Now, before we get into this, I want to give you a conceptual understanding of what the Cartesian product is. If you take the real numbers and cross the real numbers, you actually get ordered pairs where all the coordinates are real numbers. This is just the plane. When you took algebra and you saw graphs, an XY graph, that is, all of those points represents the cross product or the Cartesian product between the real numbers and the real numbers. And so in this case, you can think of doing the same thing. You're crossing A and B, and the points that you get in A cross B is the set of coordinates 1, 3, 1, 4, 1, 5, and then 2, 3, 2, 4, and 2, 5. Let me make that better. And that's it. So that's A cross B. These are all the coordinates where the first coordinate is an element of A and the second coordinate is an element of B. All right, so the question is, what is the size of A cross B? What is the size of A cross B? I'm going to make a little bit more room here so you all can see. What is the size of A cross B? Well, to figure this out, we write out A cross B. In this case, we did. It's 6. But how do we figure this out in general? Well, to do that, and I'm going to need a lot more room for this. To do that, we first have to write our set A as just a generic set of elements. A1, A2, A3, all the way up to AM. So the size of A, we're just saying, is some number M. And now B, we're going to define as also a generic finite set. B1, B2, B3, all the way up to, we're going to go to Bn. All right, so the size of A is M and the size of B is N. The set, and I'm actually going to write that down. That's a really important thing. The size of A is M. The size of B is N. The set A cross B contains all pairs with the first half of the pair being some AI in A. So we're looking at some AI B sub J, where these are elements in A and these are elements in B, and we're trying to find the size of A cross B in this scenario. Okay, so A cross B equals, well, I'm going to write it like this. I'm going to make some more room here. A cross B we can say is, well, it's the set, but that was weird. Let me try it. Oh my goodness, something's going on every time I do that. Here we go. Okay, so the size of, or A cross B, what does that look like? Well, there's A1, B1. That's in there. There's A1, B2. And technically all the way up to A1. And it's going to send me back every time I hit the back button. That's what it is. Don't hit the back button. Learned. All right. All the way up to A1BN. So we listed off all of the coordinates with A1, and then we're going to go to A2, B1, A2, B2, all the way up to A2BN. And then technically we're going to go all the way, we're going to do this over and over again, all the way to AM, B1, AM, B2, all the way up to AM, BN. These are all the possible coordinates where the first element is in A and the second element is in B. So notice what we've done here. We made M rows of N pairs for a total of M times N pairs. Each row here is really just, well, we can write this first row as A1 cross B. This here is A2 cross B. And so A cross B is just this union that all the way down to AM cross B. And then each of these individual sets are size N. So we're doing N plus N plus N plus N, M times. I know that's a little confusing because N and M sound just alike. But trust me, there are M times N pairs here, meaning that the size of A cross B is just M times N, or the size of A times the size of B. So if you ever want to find the number of coordinates in the cross product, it's just the size of A times the size of B. And again, this is assuming everything's finite here. Anyways, thanks everyone, and I'll see you in the next video.